Hello everyone, I hope you all are well. Welcome to our YouTube channel The Engineering Projects. Today, I am going to give you a detailed overview of Arduino Nano. We will first discuss the related theory, and later we'll simulate it in Proteus software. So, let's get started. I have divided this tutorial into 4 parts. In the first part, we will discuss the basic introduction of Arduino Nano, like what is Arduino Nano, why we need to use it, why is it so famous, etc. In the second part, we will discuss its hardware architecture, where we will have a look at its pinout and different functions associated with these pins like communication protocols, PWM, etc. In the third part, I will show you how to add its library to Proteus software for designing its simulation. And finally, in the last section, we will design a small simulation in Proteus software, in which we will blink an LED using NanoBoard, so that you guys could get an idea of how to practically work on this microcontroller board. I have also shared a complete tutorial on my blog and its link is given in the description of this YouTube video. Now let's have a look at what is Arduino Nano. If you have worked on any microcontroller before, like PIC or Atmel, then you must have the idea that a programming code is uploaded in the microcontroller. A developer writes the programming code in C or assembly language, and then compilers are used to compile those codes. These compilers simply create the hex file of the code, and this hex file is then uploaded in the microcontroller using a burner or programmer, as we use Picket3 for uploading code to PIC microcontroller. Moreover, in order to operate a microcontroller, we have to design its basic circuit first, where we use a crystal oscillator for frequency, and a master button for reset. Without a basic circuit, we can't operate a microcontroller. So, it's quite difficult to work on a standalone microcontroller. It involves circuit designing, plus you have to purchase a programmer or burner in order to upload code. Arduino has solved both of these problems by creating these small plug-and-play boards. We don't need to design the basic circuit or to buy any external programmer. Instead, we just need to plug our board in the laptop, install its driver, and we are good to go. That's the reason Arduino boards have become so popular, as they are too easy to use. So, Arduino Nano is a small, flexible and breadboard-friendly microcontroller board, developed by Arduino.cc. The microcontroller used in Arduino Nano is ATmega328. The basic circuit of this microcontroller is already designed on this board. As you can see here, we have this crystal oscillator. Arduino Nano comes with a crystal oscillator of 16 MHz. A driver called bootloader is pre-installed in the Nano board, which makes it compatible with Arduino IDE, and thus there's no need to use an external programmer for uploading code. It comes with an operating voltage of 5 volts, however, the input voltage may vary from 7 to 12 volts. Arduino Nano is a smaller version of Arduino Uno, thus both have almost similar functionalities. Arduino Nano is used in embedded projects, mostly in automation, robotics and instrumentation. Because of its small size and low cost, Nano is normally preferred over Uno, especially in robotics projects. Now, let's have a look at its pinout. Arduino Nano contains 14 digital pins starting from D0 to D13, it has 8 analog pins starting from A0 to A7. Each of these digital and analog pins is assigned with multiple functions, but their main function is to be configured as either input or output. Let's understand it with an example. If you are interfacing any sensor, let's say temperature sensor with Arduino Nano, then in order to read the sensor's data, the Arduino pin should act as an input pin. But if you are interfacing any motor, the motor has no data to send. Instead, it's waiting for the instructions, and as we send commands from the microcontroller, it will start rotating either clockwise or anti-clockwise, depending on the instructions sent from these pins. So, in such cases, Arduino pins will act as output pins. We have to define in the programming whether we want to use them as input or output. As I mentioned earlier, other than acting as input or output, these pins are capable of performing several other functions. These functions are pin-specific. Let's discuss them in detail. Arduino Nano is capable of performing 3 types of communication protocols, named as Serial Protocol, SPI Protocol and I2C Protocol. Pin number 0 and 1, both are digital pins, but can also be used for serial communication, where pin number 0 is RX, used to receive serial data, while pin number 1 is TX, used to transmit serial data. We have to define it in the programming, whether we want to use these pins as input-output pins, or want to perform serial communication. As I said earlier, these functions are pin-specific, means if we want to interface any serial module with Nano, Then we have to connect it with pin 0 and 1, it won't work on any other pin. Although, we can create software serial on other pins if we have to interface multiple serial modules with Arduino Nano. Check the software serial library for more details. Now let's have a look at SPI protocol. SPI protocol is carried out by 4 pins, which are pin number 10, 11, 12 and 13, where pin number 10 is SS short for slave select, pin number 11 is MOSI short for master out slave in. Pin number 12 is MISO, short for master in slave out, and pin number 13 is SCK, short for serial clock. So, using these 4 digital pins we can perform SPI protocol in Arduino Nano. The third protocol is I2C protocol. Pins used for I2C protocol are A4 and A5, these are analog pins. Here, A4 is SDA, short for data line, and A5 is SCL, short for clock line. Again, we have to define it in the programming, how we want to use these pins. Now let's have a look at few other functions these pins offer. So, Arduino Nano also has these 6 PWM pins, pin number 3, 5, 6, 9, 10 and 11. These pins are used in projects where you want to generate a modulated signal. For example, if you want to control the speed of a DC motor, you have to use any of these pins to generate the PWM signal. Pin number 2 and 3 are used for generating external interrupts, where pin number 2 is int0, short for interrupt 0, and pin number 3 is int1, short for interrupt 1. Check attach interrupt function for more details. It also has a built-in LED attached to pin number 13, which will turn on if you make this pin high and will turn off as the pin got low. It also has 2 reset pins used for resetting the board programmatically. Making this pin low will reset the board. There's also a reset button present on the board. Arduino Nano has a crystal oscillator of frequency 16 MHz. It doesn't come with a DC power jack or USB port. Instead, it has a mini USB port, which is used for interfacing Nano with the computer to upload programming code. Power is also provided through this mini USB port. This mini USB port is internally connected with hardware serial pins 0 and 1. So, if you have connected any module with hardware serial pins, you won't be able to upload code. It also has 4 LEDs embedded on it. One is connected with pin number 13, second is power LED, it turns on if Arduino Nano is powered up. Third and fourth LEDs are connected to RX and TX respectively, and they will start blinking if there's any serial communication. Now, let's have a look at the built-in memories present in Arduino Nano. Arduino Nano comes with 3 types of built-in memories, named flash memory, also called ROM, SRAM memory, also called RAM, and EEPROM memory. Arduino Nano has a flash memory of 32 kilobytes. It's a non-volatile memory, meaning the data in ROM memory will remain intact, even if we remove the power supply of the Nano board. As it's a non-volatile memory, that's why it's used for storing the programming code or any permanent settings. Bootloader is a software code which is pre-installed in every Arduino board. It's installed in the flash memory of Arduino Nano and takes around 0.5 kilobytes space, so from 32 kilobytes flash memory, 0.5 kilobytes memory is already occupied by the bootloader. Second one is SRAM memory, it's short for static random access memory, and usually called RAM memory. Arduino Nano has a RAM memory of 2 kilobytes. It's a volatile memory, so if we reset or restart the Nano board, RAM memory will get erased. This memory is used to store temporary data like variables. Third type is EEPROM memory. Arduino Nano has an EEPROM memory of 1 kilobyte. It's a semi-volatile memory and thus can be erased by programming but remains intact if power is lost. So far, we have studied the theoretical knowledge about Arduino Nano. Now let's practically work on this powerful tiny board. I am not going to work on a real Arduino Nano board, instead I am going to design its simulation in Proteus software. If you want to learn the Arduino programming language, then I would recommend you to design simulations in Proteus. Working on real hardware is quite difficult, as you have to purchase the components and it also involves electronics. In Proteus simulation, you just have to design your circuit once and then you can completely focus on your programming side. When I work on Arduino projects, I normally design my programming algorithms in Proteus, as testing with real hardware is too time-consuming. Proteus doesn't have Arduino boards in its components library, but we have designed its library, which you need to install in your Proteus software, and you will be able to simulate Arduino boards in it. We have designed 2 libraries of Proteus containing Arduino Nano. I have given both of these links in the description of this YouTube video. This library is titled as Arduino Nano Library for Proteus version 2.0. If you install this library, it will only add Arduino Nano board in your Proteus software. In order to download it, click on this download button and it will open this download page, where we need to wait for 20 seconds. And here's the link generated. Let's click on this button to download zip file, and here we got our zip file for Arduino Nano Proteus library. I am going to click on cancel, as we will install this second library. This library is titled Arduino Library for Proteus version 2.0, and by installing this library you will get these 6 basic Arduino boards. So, let's install this second one, and again we need to click on the download button. Here's the download page, and again we need to wait for 20 seconds. Let's click on this button to download zip file of Proteus library. Here, we got our zip file. Let's click on open with. Open this folder, and here we have this folder named Proteus library files. This zip file also has a simulation ready to simulate, but we will design it from scratch in a minute. First, we need to add these 2 files in the library folder of our Proteus software. So extract these files and now click on C drive. Program files. Here we have Lab Center Electronics, and then Proteus 7 Professional. Click on Library folder and now click OK. As I already have these files in my library folder, so I am going to click on Yes to all. That's it. We have successfully placed these 2 files in the library folder of our Proteus software. Now let's open our Proteus software. And in the Components section make a search for Arduino Nano. Here select Arduino Nano V2.0 and click OK. Let's place Arduino Nano in the workspace. Now we will also need LED and resistor, so let's add them. Make a search for LED, and here I'm going to select LED yellow. Next, we need to make a search for resistance. Add it too, and close this dialog box. Let's place LED first in our workspace. And next we need to place the resistance. Now we need to click on Terminals mode and place ground in the workspace. Let's connect these components. I have simply connected an LED with pin number 13 of Arduino Nano. Let's run our Proteus simulation. And we got this error, program property is not defined. Actually, we haven't uploaded any code in our Arduino Nano board. So, let's open the Arduino software. And here we need to click on File, and then Examples. Next click on Basics, and here we need to select the blink example. This Arduino sketch will blink the LED connected at pin number 13. Let's compile this blink code to generate the hex file. As I have said in the start of the video, we have to upload the hex file in our microcontroller, in order to make it work. Arduino IDE also generates a hex file and places it in the Windows temporary folder. And we can get its link from this output window. If you are not getting these weird commands in your output windows, then click on File, and then Preferences. And here we have this option called Show Verbose Output During, and tick this compilation box. We need to copy this link to the hex file. Now double click on Arduino Nano, that will open its Properties panel. Here, in the Upload Hex File section, we need to paste the link of our hex file, which we copied from Arduino software. Click OK. And now let's run our simulation. Our simulation is working fine, there's no error as we have added the hex file, but the LED is not blinking. Yeah, I missed something. Let's stop the simulation and double click on this LED to open its properties panel. And here we need to change this model type from analog to digital, and click OK. Now let's our simulation again. And yeah, everything's working fine, and our LED is blinking with a delay of 1 second. Let's stop this simulation and make some changes in the Arduino code. Let's change the delay from 1000 to 100 and compile the code again. As we have already added the hex file, so we don't need to add it again. Simply restart your Proteus simulation, and here we go. As you can see, the code has taken its effect and now the LED is blinking quite rapidly. You must have understood by now why I was preferring the simulation over real hardware. It's too easy to work on the simulation, so if you are new to Arduino, design simple projects in Proteus and practice as much as you can. So, that was all for today. I hope you guys have enjoyed today's tutorial. If you have any questions related to Arduino Nano, then ask in the comments. You can download this simulation from our blog post, link is given in the description. Thanks for watching. Have a good day. Bye.